All right, so special triangles. So we're learning to use the special triangles to find exact trig values. So your calculator stores all the approximate trig values. Like if you type in sine of 30 degrees, it'll give you, or that's not a good example because that is exact, but if you type in the sine of 60 degrees, for instance, it will give you a decimal, okay? But we can find exact values, and we use multiples of 30, 45, and 60 because those are the most common trig angles. They're kind of like benchmark angles. They're the ones you would refer to most often. So rather than 28 degrees, you deal with 30 degrees, okay? And these are the ones we want to know exact values of, okay? And you'll find, like, again, people ask me, what am I going to use this for? Well, I'm thinking first year calculus. I get all the way to the end of the integral, and I have to know what the cos of, and it wouldn't be 30 degrees, it'll be in radians, so the cos of pi over 6, which you'll learn next year in advanced functions if you take it, is, and you just need to know that. It's just like a times table. You need to know what 3 times 7 is, you need to know what the cos of pi over 6 is, the sine of it. Okay, and that all has to do with special triangles. So that's what we're going to learn today is the special triangles. Mr. Salawiga is a huge fan of special triangles, so I'm going to show you exactly his method for doing all this. It makes a lot of sense, works really well, and then when you take advanced functions next year, you'll know how to do it. Okay? All right, so we're first going to find the sides of the 45-degree special triangle. So here's my 45-degree special triangle, and notice it's a right triangle where I drew the, so you could imagine that that's the origin, and this really extends out with an arrow on the end. And then this is where I decided to pick my point and then draw my vertical down. Does that make sense from what we've been doing so far this year? And they're also showing me that the radius is 1. Okay, and this is a 45-degree angle, this is 90, so what does that make the angle at the top? How do you know that? Everyone good with that? The angles all add up to 180. So a 45-degree angle is actually, what special word could I call it? You know the name of a triangle that has 2 equal angles? The name of a triangle that has 2 equal angles? That's 3 equal angles. Isosceles, good. Isosceles, the 2 sides that are, like if you crisscross the angles, the 2 sides opposite them are equal. Okay, that's what isosceles means. So if the 2 angles are equal, then those 2 sides are also equal. Okay, it's an isosceles triangle. Does everyone agree that it's a right triangle, so it satisfies Pythagorean theorem? So I can use r squared equals x squared plus y squared, where this is x and this is y. But in this particular triangle, what's special is that x and y are equal. Everyone good with that? Because it's isosceles, x and y are equal. So I can replace y squared with another x squared. And do I know r? It's 1 squared, good. And then x squared plus x squared gives me what? 2x squared? And 1 squared is just 1. So I can solve for x, the length of x, which is also going to give me the length of y, because x and y are equal. So how would I find the length of x solving that equation to get x by itself? Divide by 2 first. Good. Reverse side mass. So I get x squared is a half. And then I have to square root. Good. And we're all positive in the first quadrant here for now, so I'll just leave them as square root of a half. But that's the same as the square root of 1 over the square root of 2. Can I take the square root of 1? It's 1. Everybody get it? Square root of 1 is 1. So x is actually 1 over the square root of 2. Okay? Which means this length over here is 1 over the square root of 2. It's x. And y is also 1 over the square root of 2. So now that all three sides of this triangle are labeled, what if, for instance, I wanted to know the secant of 45 degrees? See my chart up there? Secant is the r value over the x value. So the r value is 1. The x value is 1 over root 2. How do I reduce, well not reduce, or simplify that? Simplify the everything. So it's 1 divided by a fraction. When you divide by a fraction, you multiply by the reciprocal. So it'll be 1 times root 2 over 1, which just ends up giving you root 2. Does that make sense? Okay, and I can do that for any one of them. I could find the cosine should be sine. Now I could find sine. The sine of 45 degrees is the y value, 1 over root 2, over the r value, which is 1. So I'm just using the y value divided by the r value. Everybody get there? Sine of 45 is the y value divided by the r value. This is the y. This is the r. When you divide by 1, does anything change? So the sine of 45 degrees is 1 over root 2. So I want you to try that out on your calculator. So first I want you to find the sine of 45 as a decimal. Make sure I'm in the right mode here and not. That I'm not telling you that information here. So the sine of 45 as a decimal, did you get 0.7071? 0.7071. Now try 1 divided by root 2 and see if you get that exact same decimal. 1 divided by the square root of 2. Does that give you the exact same decimal? Now, the 0.707, that's a rounded number, whereas that's exact. Okay? And getting exact values is really important when you're doing integrals in calculus. Okay? Getting exact angles and exact values rather than approximate values. Anything exact is nicer and prettier than anything where you have to write out a bunch of decimal places. Okay? Another interesting one for this one is the tangent. The tangent of 45 degrees is the y value divided by the x value. So what's interesting here is that the y value and the x value are the same. So if you divide a number by itself, what do you end up getting? 1. And also check that out on your calculator and make sure you get 1 for the tangent of 45 degrees. Okay, so what I want you to connect is that if you have the 3 sides, then you can get any trig ratio they ask you for just by subbing in the correct sides. Okay? All right, so this is our 45-degree triangle. Now we're going to move on to the 60-degree triangle. It's a bit harder to prove here, but we will. So we have the r equals 1. I've already put the 30 degrees is up here if this angle is 60. And again, we're taking the idea that we've got a terminal arm here. And we've chosen this specific point where r is 1 to draw down our right angle triangle. And now our job is to find what x and y are. Okay, so we don't know these. And I'm going to show you how we get them. Got it. So if I put in a line there, does everyone see that this from here to here is 1? Because it tells you it is. And how long is that side there that I just dotted, the dotted side? 1 as well? How come? How do you know? I won't call it R, I'll just say it's 1.
Because it's like a reflected of the other side. So
Okay, so you use symmetry. Okay, perfect, yeah. Yep, Owen? It's an equilateral triangle now because this is 90, this bisects this, so this is also 30, and this is 60. And equilateral means that angle, and 30 plus 30 is 60. So all 3 angles are the same, so all 3 sides are the same. Perfect. Okay? So either way, that's lovely. Okay, so we've got an equilateral triangle now where all these 3 sides are the same. And then I'm going to just rewrite the bottom one because I only want to use half the bottom one. So that's my equilateral triangle. What's this side like? X. You should just be able to figure it out from the diagram. 1/2. Okay, so this vertical bisects this side. So it cuts 1 in half and makes this half and then this half. So we have x being half and r being 1, and it's Pythagorean. So this triangle is Pythagorean. It's a right angle triangle. So I can use r squared equals x squared plus y squared. R is 1. X is 1/2. And y is what we want to determine. So 1 squared is 1. What's a 1/2 squared? 1/4, good. And I want to get y by itself, so I'm going to subtract 1/4 on both sides. Easy fraction, what's 1 take away 1/4? 3/4. Okay, so you have $1, you take away 1/4, you got 75 cents, which is 3/4. Okay, so 1 subtract 1/4, how many quarters do you have? 3/4 left. Okay. That's y squared though. I want to know plain y, so what would I do to both sides? Square root. So that's going to tell me that y is the square root of 3 over the square root of 4. Can either of those be, is either of those a perfect square that I can take the square root of? 4 is. So I'm going to leave root of 3 alone because it's a decimal, but root of 4 is actually 2. So that means this side over here, y, is root 3 over 2. So this side here is root 3 over 2 is y. Now in the diagram, does root 3 over 2 look like it's longer than 1/2? Yes, so let's just check it on our calculator. So we know 1/2 is 0.5, root 3 divided by 2. It's about 0.866. Okay, so it's longer. So always keep in mind that root 3 over 2 is longer than 1/2. Okay, and then you always know the diagonal 1 is longer. It has to be the log side, it's a hypotenuse. Okay, all right, so now we know all 3 sides there. So we can pick any relationship. We could do cosecant of 60 degrees. And it would be the r value, which is 1, divided by the y value, which is root 3 over 2. Now you never want a 3-layer fraction that's not considered simplified, so you have to do the divide. So the cosecant of 60 degrees would be 1 times 2 over root 3, for instance. Multiplied by the reciprocal. And the cosecant of 60 degrees would be 2 over root 3. That's the exact value. Okay? Tan's always a good one to try. So the tan of 60 degrees is the y value divided by the x value. Divide by fractions, multiply by the reciprocal. So root 3 times 2, I could write as 2 root 3. 2 times 1 is 2. What happens to the 2's? They do. So the tan of 60 is going to end up being exactly the square root of 3, and we're going to test this one out using our calculators. So tan of 60, just do tan of 60 on your calculator, and the decimal you get should be 1.73205. Now just try root of 3 as well, and see if you get that same decimal. Yeah. Okay, so that's the exact value of the tan of 60 is square root of 3. I just want to show something else too here that happens a lot in trigonometry, special triangles, is when you're dividing two fractions that have the same denominators. Two fractions that have the same denominators, the denominators cancel out and you can just divide the two numerators. Okay? You see what ends up happening? You multiply by the reciprocal, and then the 2's end up dividing out. You can divide them out here, and then just say it's going to be root 3 divided by 1, which is 1. Okay? Because you're dividing things that are out of the exact same, so the denominators don't matter if they're exactly the same. You can't pull them out of that step, and just save yourself some time. And this happens over and over again in trig, so it's a good trick to know. All right, the 30-degree triangle is just a rotation of the 60-degree. Okay, so remember it's got the same three angles as this one has. It has a 90, a 60, and a 30. So the three sides should be the same length. Okay, it's just a rotation. So we know that the diagonal is 1. Now which was longer, the half or the root 3 over 2? Root 3 over 2. Root 3 over 2. So root 3 over 2 is going to be the x side. And the y side is going to be the half. Okay? So then I could use any of my formulas over here to find exact values. I could find sine of 30 degrees. It's going to be the y value divided by the r value. So for us, the y value is a half, and the r value is 1. Divided by a half doesn't change anything, so you just get half. Exactly. So if you were to type in sine 30 on your calculator, you'll get 0.5, which is exactly a half. Okay, let's try cotangent. No, let's try tangent actually. So tangent of 30 degrees is the y value, which is a half, divided by the x value, which is root 3 over 2. the y value divided by the x value. Do you see that again? Both of these are out of the same denominator. So I should be able to cancel those denominators out here and say that the tangent of 30 degrees is 1 over root 3. Now I've got a 2-layer fraction. So let's try it out on our calculator and see if we get the same decimals. So the tangent of 30 is approximately 0.57735. And then 1 divided by the square root of 3 is 0.5773, exactly the same decimal. Okay? Okay, so those are our special triangles, and now we'll see why and how we're using them. So use special triangles to determine the exact value. Draw a label diagram of each angle in standard position. So cos of 120 degrees. So back to this morning, 0, 90, 180, 270, 360. Where would 120 go? Which quadrant and closer to the x or closer to the y? Closer to the y in the second? Good. So here's 120 degrees. Now, in these questions, alpha is always going to be 30, 45, or 60. Alpha is always going to be 30, 45, or 60. Okay? So, again, alpha is this angle in here. How would I figure out what alpha is? 180 minus 120. So I'll just do that here. Alpha is 180 minus 120, which is 60. Everybody good? So this angle here is 60 degrees, that's alpha. And then I'm going to choose a point along my terminal arm and draw my special triangle. Not just a triangle anymore, it's special. Special. So it's the 60-degree special triangle, which you have to memorize, okay? So we know that R is always 1. So that's always easy to put on. Now, 60 and 30 are related. The longer side is the root 3 over 2 side, and the shorter side is 1/2. Now, those are the lengths. But I have to consider the quadrant I'm in. I'm in quadrant 2. So does it make sense for either my x value or my y value to be negative? Everyone see x value should be negative? So if you were plotting a point right here, you would go this way negative 1/2, but you would go up root 3 over 2. And r is always positive. You never have to worry about r. You just have to worry, should x or y or both be negative? Okay? So now you've labeled your special triangle. Now you're going to go and answer the question, which is they want the cosine of 120 degrees. So the cosine of 120 degrees is the x value over the r value. Does everyone see that formula? Okay, so I'm looking on my special triangle. The x value is negative 1/2. The r value is 1. Negative 1/2 divided by 1 is negative 1/2. So the cosine of 120 degrees is negative 1/2. Test it out on your calculator and see if you get negative 0.5. Yeah? Okay. All right, so next one is sine of 315 degrees. So we'll start off just the same as this morning. So 315, is it going to be closer to the x, closer to the y, or in the middle? It would be in the middle, yeah. So I'm going to draw it right in the middle. And then I'm going to label it. So this is 315 degrees. But alpha is going to be a special triangle. It's either going to be 30, 45, or 60. And I could get it by doing 360 minus 315. So it's 45. So then you just pick a point along your terminal arm, draw to the x-axis, and now you've made a 45-degree special triangle. So you want to label the three sides according to it being in quadrant 4. So we know R is 1, so that's easy. It's always positive, and it's always 1. The special triangles. The 45, the x and y were the same, it's isosceles. You just have to remember what they actually are. Yep. 1 over root 2. So before we consider signs, they're both going to be 1 over root 2. Does it make sense for x to be positive or negative? If you're plotting this point down here, you would go in the positive x direction, but then you would go in the negative y direction. So y should be negative, and x should be positive. Any questions about how I know that? If you want, you can do like a little x and y are both positive in the first quadrant. In the second quadrant, x is negative, y is positive. In the third quadrant, x and y are both negative. And in the fourth quadrant, x is positive and y is negative. Okay? It's just kind of like a review of when you're plotting points in grade 9. That's just the way it is. Okay? All right, so we haven't answered our question. What we set ourselves up to be able to. So they want the sine of 315, and sine is the y value divided by the r value. So I have to look at my diagram, and the y value is negative 1 over root 2 over the r value, which is 1. And then divided by 1 doesn't do anything. So the sine of 315 should be negative 1 over root 2. Exactly. So try both ways on your calculator. So try the sine of 315, negative 0.707, and then try negative 1 divided by root 2. And you get the same this one. Okay? So you can always check for yourself. Sine of 600. Okay, so I know it's going to be in the third quadrant because it's 600, closer to the x or to the y. Okay, no, closer to what? Closer to what? Okay, good. Because it's 600, and you only have to get 30 degrees to get to 630. Yes? Okay, so if I'm drawing the angle on, I'm going to go around 1 time, and then to the terminal arm. There's my angle. And we need alpha. Alpha is either going to always be 30, 45, or 60 when we're dealing with special triangles. So to get alpha, what do I need to do? Alpha is going to be my terminal arm angle, which is 600. Take take away what's always towards the x-axis, 540. Gives you 60. So alpha is 60. Which means you're going to draw in the 60 degree special triangle. Only it's in the third quadrant. So see if you can label X, Y, and R with the proper values and the proper sign. Remember, 60 and 30, the longer side's root 3 over 2, and the shorter side's 1/2. Okay, so R is going to be 1. Who thinks they know what X is going to be? This doesn't look really vertical. That doesn't look vertical either. I'm trying to get this done. No, it's not my day. Pick a line. Line. Okay. There we go. That's pretty good. Cover that red. Okay, so R is 1. What did you get for X? 1/2. Negative 1/2. Good. What are you going left? And what did you get for Y?
Negative 33.
Negative root 3 over 2. And R is always positive. Okay, so now you've got your special triangle drawn with your 3 sides labeled, so you should be able to get any one of those 6 they ask for. So in this case, they ask for the sign. So that's the Y value, which is negative root 3 over 2, divided by the R value, which is 1. Dividing by 1 doesn't change anything, so it should be negative root 3 over 2, and you can check it on your calculator. So try sine of 600, negative 0.8660. And then negative square root of 3 divided by 2, same decimal. Okay? Tan of 150. So we want to draw it 150 first. Can already stop at 180. Okay. So 150 is going to be in the second quadrant, closer to the x-axis. So here's 150 degrees. What's alpha going to be? So it's going to be 180 minus 150, which is 30 degrees. So that means you want to label the sides according to a 30-degree special triangle in the second quadrant. So R is 1. What did you get for the x side?
Negative root 3 over 2.
Yes. And the y side, Sam?
1/2.
Good. And R so you got your three sides labeled, so now you go up and see what are they asking you for? Tan. So that's the y value divided by the x value. So that's going to be positive a half divided by negative root 3 over 2. And if I'm dividing two fractions and the denominators are the same, I can cancel them. Which leaves me with 1 over negative root 3, but they're never going to leave a negative in the denominator of a fraction, so you'd rewrite that as either the negative even with the fraction bar or with the numerator. So that's the exact value of the tan of 150, and then you can check that with your calculator. Tan of 150, negative 0.57735, and then negative 1 divided by root 3. Same. Okay, E, cosecant of 210. So first we're going to draw 210 degrees. So 210 is going to be the third quadrant, closer to the x or to the y. Yeah. Okay, so this is 210 degrees. And then we need to know what alpha is, so we know what stuff of triangle we're dealing with. So alpha is going to be 210 minus 180, which is 30 degrees. So I know it's a 30-degree special triangle. And then I want to label the three sides. I know R is 1, according to 30-degree special triangle and also being in quadrant 30. What did you get for x for this triangle? Negative root 3 over 2, yep. And for y?
Negative 1.
Yes. Any questions about how to get the sides? No? Okay, so now we just need to figure out what ratio we're talking about. Cosecant of 210 degrees. So then cosecant is r over y. So it's 1 over the y value, which is negative a half. This is dividing by a fraction. So we know we're going to multiply by the reciprocal, which just ends up giving us negative 2. I've got a question. How can I check that on my calculator? There's no cosecant button. One over sine. There you go. That's an identity. From yesterday, we know that cosecant is 1 over sine theta. That's an identity. So try 1 divided by the sine of 210 on your calculator. And then also, well, we want it to be negative 2. So 1 divided by the sine of 210 degrees should give you negative 2. You see that? So you used an identity in order to make sure that you know you're right. Okay? It's awesome. Good job, right? Okay, the secant of 315 degrees. Secant of 315. So I think I'll just give you some time to try that one. Okay, so. So did you guys get halfway in the fourth quadrant? Okay. And divide that by 220. Oh, 270. Okay. So if you did 360 minus 315, you would get 45. And I have to draw on my 315. So again, to get alpha, you can do 360 for this one, and then subtract 315, and that gives you the 45. Draw in your right triangle always with the x-axis. R is always 1. And for the 45-degree triangle, the x and y are the same. They're 1 over root 2, but then you have to make sense of what quadrant we're in. So this x would be positive 1 over root 2, and y would be negative 1 over root 2. Okay? And then it's asking you for c, which is r over x. So r is 1, x is 1 over root 2. And then you divide by a fraction, you multiply by the reciprocal. So you end up getting root 2. Yeah? Okay. And then you can check it on your calculator by doing 1 divided by the cos of 315. But identity is that sec is 1 over cos. I got 1.4142, and then root 2 is the same decimal 1.4142. Okay? So the identity we use to check is that sec of an angle is equal to 1 divided by the cos of the angle. Okay? Okay, G, 840 degrees. All right. And we're going for 840, so it's going to be between 810 and 900. Yep. No, I'm just doing that to help you. If you don't need it, then you're good. Okay. So do you guys? It's going to be the second quadrant closer to the y-axis. Yeah. Oops. Okay, that's better. Okay, so 810 is going to be all the way around once is 360, twice 720. That's 810. Sorry, that's 840. And then alpha is going to be 900. That's my benchmark angle minus my 840. Gives me 60. And then I can draw in my vertical. And now I've got my 60-degree right triangle. And I have to label it according to it being in the second quadrant. We know R is 1. X to be -1/2. And y to be positive √3/2. And then see what ratio we're asking for. So cotangent is x value divided by y value. So -1/2 is the x value divided by the y value, which is √3/2. X divided by y. And then we have fraction divided by fraction where they have the same denominators. So I can divide them out now. So I end up getting -1/√3. And I could check that one using the identity that cotangent beta is 1/tangent of beta. So I could do 1/tan of 840 and then make sure it's the same decimal as -1/√3. And then I would know my answer was right. Okay? So 1/tangent of 840 is -0.57735. And -1 divided by the square root of 3, -5.7735. Okay? All right, cosine of -225 degrees, so a negative angle. So negative, is it 225? Yep. So in the second quadrant, halfway, up. And alpha is 45 degrees. And this is -225 degrees. So you want to label the 3 sides of the 45-degree right angle triangle that fits into the second quadrant. One. 45-degree triangle, they have the same size 1/√2, but in the second quadrant, x is going to be -1/√2, and y is going to be positive 1/√2. And we want the cosine of it, so that's the x value divided by the r value. So that's it's 1. Nope, it's -1/2 over 1. Divided by 1 doesn't change it, so it's just -1/2. And then that one you can just type in your calculator. Just post it on your calculator of -225, -0.707, and -1 divided by √2. Save. Cosecant of 510. what did we say? 510. So that's going to be in the second quadrant, closer to the x-axis. So 510 all the way around west. And then alpha is going to be 540 minus 510, which is 30 degrees. What do you think x is? Yes. And y is 1/2. Good. All right, so then we want to find the cosecant, which is the r value divided by the y value. So 1 over 1/2, which is 1 times 2 over 1, which is 2. And then you can use the cosecant as 1 over sine identity. Check your answer. Make sure you get 2. All right, Jay, I'm going to do a little bit differently. I want to show you another way to do it. I'm just going to pause now. Maybe so, what if you had to draw the angle? What if you had to, sorry, not draw. What if you had to find the secant of an angle like 8,760? Like, would you want to keep drawing around and around forever? No. If you find the principal angle of an angle, is it going to have the same sine, cos, tan, cosecant, secant, and cotangent of the original? Yes. So if you look here, if I've just drawn the principal angle, which would have ended up being 150. If I did a cosecant of 150, it should still give me 2. So try that. So try 1 over sine of 150. Do you see that it still gives you the exact same answer? So coterminal angles have the exact same 6 trig ratios. Okay? So I'm going to do this one a little bit differently just so that you see that I can do it. So what I want to do is first find the principal angle of negative 690. Okay, so my first step is I'm just going to change this angle to a positive angle between 0 and 360, the principal angle. So I know that I'm starting in the negatives, so I'm just getting the principal angle here. If I'm starting with a negative angle, I'm going to add 360 and see where I'm at. So negative 690 plus 360 is negative 330. So I'm still in the negatives, which means I have to add 360 again. And that ends up giving me 30. So a true statement, true, is that the sec of negative 690 is equal to the sec of 30 degrees. So my equals holds. This is exact truth here. Okay? Which means now I can just draw 30 degrees, which is way easier to draw than negative 690. Does everyone agree? So 30 I know is in the first quadrant, closer to the x-axis. I know alpha is 30 because it's the principal angle and it's in the first quadrant. So now I'm drawing the sides of a 30-degree special triangle that's in the first quadrant. So I know for a 30-degree, r is 1, that's easy. The longer side, which is x, is root 3 over 2, positive, because we're in the first quadrant, and the y value is 1/2, because we're in the first quadrant. Okay? So saying this statement is showing me that you can now just draw 30-degree angle. Okay? Because you know these are the same. You've done this work either on your calculator, somewhere else, so that you know these are the same. So then your second step is, well, I want to find the sec of 30. So I need to know sec is r over x. So r is 1, x is root 3 over 2. That's a divided by. So I'm going to multiply by the reciprocal. And I end up getting 2 over root 3. And then we can check it using our identity. So 1 over the cos of negative 690 should be the same as 2 over root 3. So 1 divided by the cos of negative 690 gives me 1.1547. 2 divided by the square root of 3 also gives me 1.1547. Okay? All right, so keep that in mind when we do our last few questions here. Find the exact value of each of the following, show your thinking. Okay, so there's lots of room to show our thinking. All right, so step 1 is going to be to find the principal angle and replace it. So cos of, actually no, step 1 is going to be to rewrite it like this. Okay, so cos squared means, of 510 means cos of 510 degrees squared. Okay. Second step is to replace 510 with the principal angle of 510. So if we start with something bigger than 360, how do we figure out the principal angle? Subtract 360 until we get to an angle that's between 0 and 360. So we're at 510, take away 360 is 150. And that's still squared. All right, so now it's diagram time. Okay? So leave some space, because you know you're going to have to use your ratios. Leave some space, and then make your diagram. So there's my x-axis and my y-axis. Oh, I don't mind kind of on an angle. I don't need it to be 150. Should be in the second quadrant closer to the x-axis, so like that-ish. So this is 150, which makes this a 30-degree special triangle. And then I want to label the three sides of a 30-degree special triangle so that it makes sense to be in the second quadrant. So that's going to be ours. X is negative root 3 over 2. And y is positive 1/2. Does that make sense? Okay, now I want the cosine squared. So first of all, I need the cosine. So cosine is x over r. So negative root 3 over 2 over 1. Dividing by 1 doesn't affect anything. So it's negative root 3 over 2 squared. And then you go back to fractions, to an exponent. So that means you can apply the exponent to the numerator and to the denominator. Does that make sense to everybody? You can apply the exponent to the numerator and the denominator. So a negative times a negative is automatically a positive. So the squared gets rid of the negative. What's root 3 times root 3?
3.
Good. It's 3. It's the root of 9, which is 3. Okay, so another way to think of it is squared undoes square root. Squared undoes square root. So I've got 3 on the top, and then 4 on the bottom, 2 squared. And I can actually test that out. I can type in the cosine of 510 and square it, and make sure that I get 0.75. So the cosine of 510, get my answer, and then square that answer, and it should tell me 0.75. And it does. Does everyone see that? You can check? Yes? Okay. All right, the tan of 330 times the sec of 150. So I'm going to have to make 2 diagrams. So I'm going to make my diagram smaller and down here. And one's going to be for 330 and one's going to be for 150. So I'm going to do 330 first. So it's in the 4th quadrant closer to the x-axis. So this is 330, which means there's only 30 degrees left to get to back to where you started. So it's going to be a 30-degree special triangle. That's in the 4th quadrant. So in the 4th quadrant, x is positive, and it's the longer side, so it's going to be root 3 over 2, and y is going to be negative a half. So there's my first diagram, ready to be used. This is my 330 diagram, and over here is going to be my 150 diagram. So 150 is going to be in the 2nd quadrant, closer to the x again, yeah. So this is 150. Again, it's a 30-degree triangle. There'd only be 30 degrees left to go to 180. Our result is 1. For a 30-degree triangle, the longer side is the horizontally x, so and it makes sense for it to be negative in the 2nd quadrant, and the y value to be positive. So this is kind of all your setup, and then you come back up to the beginning of the question, and then you should be able to replace tan of 330 with from the 330 diagram, the y value, which is negative 1/2, divided by the x value, which is root 3 over 2. And these are the same. So the tan of 330 is this. Okay? And then the sec of 150. So I got my 150 diagram, and I want the r value divided by the x value. So 1 over negative root 3 over 2. So this sec of 150 is this. Everybody good so far? So we want to end up, our final answer should be a 2-layer fraction. Okay? So first let's clean up this one. This one we're lucky because we have 2 fractions dividing each other with the same denominator. So we can just divide the denominators out. And this becomes negative 1 over root 3. This one, when you're dividing by a fraction, you multiply by the reciprocal. And it looks like I have double brackets here, but I have the 1 times negative 2 over root 3 multiplied by the reciprocal, but then it's multiplying this. So that's going to give me negative 1 over root 3 times negative 2 over root 3. And then when you multiply 2 fractions, you multiply the tops together. So negative 1 times negative 2 is positive 2. Root 3 times root 3 is 3. Good. So root 3 times root 3 is either you can think of root 9, which is 3, or you could go, it's root 3 squared, which is 3. So that's a challenging way to write 2/3. Tan 330 times sec 150. And you could check it on your calculator again by doing tan of 330 times 1 divided by the cos of 150. And it should give you 0.6 repeat, which it does. Okay. Last question.
Another one?
Another one. So first thing I would do for this one is if something's not a principal angle, I would turn it into 1. So I'm happy with the 315 because it's between 0 and 360, but I'm going to change sine of 120 to a positive number. So negative 120 plus 360 is 240. And now I go and make my 2 diagrams. Okay, so 315 is halfway in this one. So that's a 45-degree triangle. And label the sides. This is grade 9, so 25.
Okay.
Thank you. Okay, so my 3 sides should be 1, x should be positive 1 over root 2, and y should be negative 1 over root 2. And then 240. 240 is the third quadrant. This is fine. Okay, so 240 minus 180 is going to be alpha. So 60-degree triangle. It's in the third quadrant. So x and y are both negative in the third quadrant. Okay, so all that work is setting you up so that you can find the answer. So the cos of 315, if you want, you could find, like you could do, here's another way to do it, you could just find the cos of 315 separately first from this diagram and then put the simplified number in there. Okay, so cos of 315 is x over r. So it's 1 over root 2 over 1, which is just 1 over root 2. And then I can come back over here and put 1 over root 2 in here. And then I can look at this diagram and figure out the sine of 240, which is y over r. So negative root 3 over 2 over 1, which is just negative root 3 over 2. And then put it in. And then I don't have like 6-layer fractions or anything crazy to look at. I'm dividing. I have this fortunate thing of the denominators are not the same. Glad I did that one actually. So now I have to do my normal, divide by a fraction, multiply by the reciprocal. So 1 over root 2 times 2 over negative root 3. So divide a fraction, multiply by the reciprocal, and I'm just going to bump the negative up to the numerator. And then multiplying is the easy operation, top by top. 1 times negative 2 is negative 2. Root 2 times root 3 is root 6. Okay, root 2 times root 3 is root 6. And then we can try that on our calculator and make sure we get the right answer. So the cosine of 315 divided by the sine of negative 120, and go right back to the original question. That gave me negative 0.81649. And negative 2 divided by the square root of 6, negative 0.81649. Okay? Okay, I know that was a lot. I hope that you caught on to it. I know we did a lot of examples, so hopefully you started to